Welcome, everyone. We will continue with the available serial communication protocols in LD Micro. In tutorial 11, we created a serial LCD that communicated with the Arduino Nano using the formatted string over UART instruction. The I2C, also referred to as I2C communication protocol, will be considered in today's tutorial. We will demonstrate how I2C can be used for LCD character display, and finally build a breadboard circuit of real-time clock with a DS3231 I2C module. But first, click on the like button, click on the subscribe button, and share this video with interested persons. Inter-integrated circuit, the full form of I2C, a bidirectional two-wire bus, was developed by Philips for efficient transfer of data between integrated circuit chips. Microcontrollers can communicate with several I2C devices, ranging from sensors, EEPROMs, real-time clock, and LCDs. I2C devices use two wires for communication alongside power supply, a serial data line pin for bidirectional data transmission, and a serial clock line pin that synchronizes the data transmission. Using LD Micro, the I2C protocol supports a single master, normally the microcontroller, and several slaves, up to 127 devices in the same two-wire bus. The microcontroller sends and receives information to and fro the slave devices, identified by a unique software address. Data transfer speed in standard mode is 100,000 Hz and 400,000 Hz for fast mode. See the link in the description below for more details on the I2C protocol. The I2C read and the I2C write instructions can be inserted in LD Micro from the I2C function option of the instruction menu. These functions are only available in C mode and with specific microcontrollers. Tutorial 12 demonstrated how to configure LD Micro to program Arduino boards in C mode. In upcoming tutorials, we will demonstrate how to program PIC and ARM microcontrollers in C mode. The I2C read instruction reads a byte of data from a slave register with a given address between 1 to 127, while the I2C write instruction writes a byte of data into a slave register specifying the slave address. To set up LD Micro for I2C read-write operation, you must first select a suitable microcontroller. PIC16F877 or 876 for PIC, ARM microcontrollers, and in this case, Atmel AVRO 80MEGA32828PDIP. This option can also be used for Arduino Nano. Let us create a sample program from LD Micro Forum by Jose Giles to demonstrate how the I2C read instruction is used. This program was made to read the seconds value of DS1307 real-time clock. Insert add instruction as shown. An if greater than 99 instruction in the same row with a move instruction as shown. Then insert an I2C read instruction in another row. Double-click on the instruction to open the configuration dialog box. Specify a variable name of sec in the receive to variable text box. Input the DS1307 I2C address as 68 hexadecimal. Then set the seconds register number of the ROTC module as 0 in the I2C register text box. Click OK. Insert BCD to bin converter instruction from the display option of the instruction menu. This instruction converts the data read from the ROTC module, which is in binary coded decimal format, to binary format. Finally, insert a compare for equal instruction and a UART send instruction in the last row as shown. Simulate the program and observe the simulation terminal for URAT is repeatedly displaying hexadecimal 0. Impute figure 3 and observe the displayed value changed. To display characters on the LCD with the I2C instruction, a PCF8574IO expander module is required. These modules also come with some LCDs. These 16 pins connect directly to the LCD pins. These are the I2C data and clock pins. Power is supplied to the module, then to the LCD via these pins. The contrast of the LCD can be adjusted with this potentiometer. And this jumper supplies power to the LCD backlight. The module is addressable by solder pads marked as A0, A1, and A2. For most modules, the address defaults to 27 or 3F hexadecimal when the pads are open. The shaded section shows the corresponding addresses when the selected pair of pads are soldered together. These values are commands used to control the LCD, where 10 hexadecimal turns on the backlight. This table shows the command values for positioning the cursor for 16 by 2 LCD and 20 by 4 LCD. The Arduino Nano uses pin A4 for SDA and pin A5 for SCL I2C communication. Now, wire up the I2C LCD module with this circuit diagram. Connect the LCL pin of the module to pin A5 of the Arduino Nano, SDA to pin A4 of the Nano, VCC to 5V pin of the Nano, and GND to GND of the Nano. To set up LD Micro for I2C LCD communication, go to the library for AV Arrow folder of LD Micro. Right-click on I2C lib.c to edit it. Locate #define LCD I2C AD arrow and change the value to your module address, 0x27 in my case. Ensure that #define LCD I2C reg below is 255 and save. To avoid always changing the true to 1 in your project.c files for LD Micro build 5.4.0.5, right-click on uslib.c to edit it. Add below the include line #define true 1 and save. This has been corrected in the latest release of LD Micro. Let us adopt another program by Jose from LD Micro forum. In LD Micro, insert a cyclic timer of 100 milliseconds with an internal relay coil named clock. Insert an internal relay contact, also named clock, that activates a secular counter with a maximum value of 110. Then the div and mode that separates the counter value into digits as in tutorial 9. This is done because the I2C function can only send or receive a single character at a time. Add 48 to convert the digits to ASCII characters, as only ASCII character can be displayed on the LCD. Insert a one-shot rising in a rung below and an I2C write instruction. Double-click on the instruction to configure the function to turn on the LCD backlight at startup. Impute hexadecimal 10 in the send variable field. Impute the I2C LCD address and the I2C LCD register that were added to the I2C library file. Then click OK. Insert a negated internal relay contact in the same rung with a lookup table from the instruction menu. Double-click on the lookup table. Change the destination field to tab, the name field to name, and the index field to letter I. Click on the checkbox below to add the text counter. The next rung has the same negated internal relay contact, an I to C write instruction, and an add instruction as shown. Add the variable tab as the send variable value of the I to C write instruction. The index I is increased by 1 to display each character on the lookup table. Note that the value 6 is 1 less than the lookup table size. The counter value can finally be displayed, enabled by arrow once contact. The first I to C write instruction with a send variable value of hexadecimal A0 sets the cursor at the first column and second row of the LCD. The other 3 write instructions displays the value of the counter. Then select MCU parameters from the settings menu. You can leave the I to C rate at 100,000 Hz in standard mode. Change it to 400,000 Hz in fast mode depending on your device support. Assign pin A5 of the Nano to I to C SCL and pin A4 to I to C SDA. Then compile Atmel AVROGCC, build C solution, and call Flash MCU to upload the code into the Nano. Observe the display on the LCD and the increasing counter value from 0 to 110. Now let's consider how to program the DS3231 real-time clock in LD Micro. This module is an I to C device that provides accurate real-time clock function with a calendar that sustains second, minute, hour, day, date, month, and year data. It supports 2-time of day alarm function with a square wave output as well as temperature measurements. The module has a battery holder with a 3-volt lithium battery to maintain the time and date when the supplied power is off. It also has an addressable EEPROM. In addition to the power supply and I to C pins, it has a 33K output for a stable and accurate reference clock, an SQW output pin associated with the alarm. The I to C address for the ROTC is fixed at hexadecimal 68. Here is the register address for second, minute, hour, day, date, month, and year. Check out the DS3231 chip datasheet for a complete list of the registers from the link in the description below. Set up your breadboard circuit with this circuit diagram containing the DS3231 module, I to C LCD, and 4 push-button switches with 10 kΩ pull-down resistors, all connected to the Arduino Nano. Create a program in LD Micro to display the seconds, minutes, hours, dates, months, and years. These can be set with the 4 push-button switches menu option. Rung 1 has the menu contact that increases a circular counter through 5 options to set the date, month, year, hour, and minute of the real-time clock. The default counter value of 0 selects the option to acquire the values of the date and time from the DS3231 module. In Rung 3, when C menu is 0, the I to C read instruction reads the second value at register 0 from the module at device address 68 hexadecimal and stores it into a variable, sec. The read value is then converted from binary coded decimal to binary by this instruction. The second value is then separated into 2 digits, converted to ASCII format, and stored in variables S10ths and S units. Similar to Rung 3 are Rungs 5, 7, 9, 11, and 13. Rung 5 acquires the minute value from register address 1 and stores the separated ASCII digits at M10ths and M units. Down to Rung 13 that acquires the year value from register address 6 and stores the separated ASCII digits at Y tenths and Y units. When X menu contact sets C menu to 1, rung 15 is enabled to set the date in the ROTC module. These I to C write instructions set the cursor at column 15, row 1 of the LCD to display a less than symbol and a character D that indicates the setting of the date, and then move the current value of the date to variable CDate. CDate variable is increased or decreased by contact XINC and XDEC. This section ensures that the selected date is within 1 and 31. The date is separated into 2 digits and converted into their ASCII values. When XEnter is activated, CDate value is moved back to the date variable, converted from binary to binary coded decimal, and sent to the ROTC module register address of 4 to set the date. Rung 17 and 19 are similar to rung 15, but set the month and year respectively. Rung 20 clears the less than symbol and the menu option indicator from column 15 and 16, row 1 of the LCD. Rungs 22 and 24 are also similar to rung 15, but they set the hour and minutes respectively. Then rung 25 clears the less than symbol and the menu indication from the LCD as before. Rung 27 turns on the backlight. Rung 28 will display the text date starting from column 1, row 1 of the LCD. Rung 29 displays the acquired values of the date, month, and year separated by a dash starting from position 86 hexadecimal. Similarly, rung 30 will display the text time in row 2 of the LCD. Finally, the hour, minutes, and seconds separated by colons will be displayed on the LCD starting from position A6 hexadecimal. Configure the push button switch input pins as the Arduino Nano pins of D2 for X menu, D3 for XINC, D4 for XDEC, D5 for XEnter, A5 for I2C SCL, and A4 for I2C SDA. Compile the program as before, build C solution, and call Flash MCU. Observe the display of the calendar and time. To adjust the calendar and time, press the menu button once. Observe a less than D at the top right of the LCD. Repeatedly press the increase or decrease button to adjust to today's date. Then press the Enter button to save. Press the menu button again to adjust the month, repeating the previous steps. Press the menu button to set the year, hour, and minute, observing the indication of the parameter to be set on the right side of the LCD until the current date and time is being displayed on the LCD. With this, you can read from and write to I2C devices with LD Micro. Please click on the like button and share your thoughts on this tutorial in the comment section. Don't forget to subscribe to this channel if you have not. Great things are coming your way in upcoming videos. See you soon.